Welcome, student. We now come to another portion of mathematical tools, which is coordinate geometry. Now, see, coordinate geometry is marriage of algebra, as you know, and geometry. So here, what we are doing is previously we had a straight line. Now we'll have an equation for a straight line. Previously you had a circle. Now you have an equation for a circle. Now you have a graph like this, which you call the parabola, and you will have an equation for this graph parabola. So our fundamental idea is to have a marriage of algebra and geometry and get what we call coordinate geometry. So now the whole portion of coordinate geometry will be taught in detail along with mathematics. But right now we will emphasize as to how this is applicable to physics. To begin with physics, rather, coordinate geometry is a very important and intrinsic portion. So if I draw a straight line like this, as you have already learned about slope, you now can tell me that this tan theta, the slope, is nothing but the ratio of y by x. So you see I'm writing it tan theta is y by x. This tan theta now is called the slope here, the gradient here, and it's expressed by the letter m. So you see I have an equation y is equal to mx. So I say that this is a fundamental equation of a straight line with a slope of m, which is tan theta. So if this angle comes to 45 degree, then I can say that the equation of this line is y is equal to x. Now, what happens if the line do not pass through the origin? I hope you understand what I just referred here. I mean to say that if the line is not like this, what happens if it is here or if it is there? Well, now we have to get at what happens in that case. In that case, what we have a thing which we call an intercept. So this, as you can see, is a positive intercept, and this, as you can see, is a negative intercept. So the whole equation of straight line can be put like for a positive intercept as mx plus c, and for a negative intercept for mx minus c. So this is what we have for a straight line. Now how we can apply this to physics? Say you are asked to draw the line of y is equal to x plus 2. So you know this 2 is nothing but here the 2 units. So we'll make it 2. And I can be sure that you now by now understand that this angle is 45. Why 45? Because m is equal to 1, and m is equal to 1 implies that the slope is 45 degree, as tan 45 is 1. So I hope it will not bother you if it is like this, y equal to x by root 3 plus 2. So in that case you know that the tan theta is 1 by root 3, and 1 by root 3, as you know, is tan 30. So in that case this slope should have been 30. Now if it is y is equal to root 3x plus 2, then I also hope you understand that the angle is nothing but 60. So this is how we progress on a straight line. Well, the straight line form is rather a much simple case. Now we come to the case of parabola and circle. For that we need to introduce uh, one more concept which we call a conic section. You just imagine a cone here, and first you cut it straight down the line. If you look from the top, this will appear to a circular shape. Now I cut it like this, a bit, not in a straight line, but in an inclined line. And if you look it for the top, it will look like this. Now this is what we call an ellipse. An ellipse is a kind of a straight line where the top is flattened and the belly goes far away from it. So the cap flattens and the belly goes out, and we call this shape an ellipse. And if I cut it from here, if you can view it from top, you'll find it like this. And that is what we call the parabola. Now, as we are concerned with these portions of the coordinate geometry only and only with physics. So we try to learn the initial case of a parabola because it is of more importance for us right now in physics. So if I consider a parabola have equations, or the two equations I will say, along the axis like this. If it is x and this is y, then I can have an equation of a parabola like this, and I can have an equation for a parabola like this. As you can see, this particular parabola is symmetrical about x-axis, and this particular parabola is symmetrical about y-axis. So now when a parabola is symmetrical about x-axis, the equation is y squared equal to 4ax. And y is symmetrical about y-axis, is given at x squared is equal to 4ay. Now just forget this 4y, this 4a, I'm sorry, this 4a, because this 4a is nothing but a constant. So we deal only with this part, that how it looks when I have a variable x square values as y, or how it looks when there is a variable which looks as y square values as x. Now let us see that how they actually look like and how they are related in physics. You see, in physics, I have an equation of kinematics which says that S is equal to half a t squared. Now if I plot S versus t, then how will this graph look like? Well, I'll try to get under this. You see, it is S and t. Now tell me, which axis is this? Well, it's x. Which axis is this? Well, it's y. So fundamentally what happens here is the equation is of a form of x squared varies as y. I hope you understand that. So this is a parabola of x squared equal to 4ay. So I hope you remember that it means that it will be symmetrical about y-axis. So I should draw it like this. And that is the reason why S versus t graph look like this. Well, we can have another expression to understand it further. I have another kinematical equation for you, which is v square equal to 2as. Now again I plot this for v along y-axis and the displacement s along x-axis. So I hope you understand now that this equation is in a form of y square varies as x. Why? Why? Because v I have plotted on the y-axis and s I have plotted on the x-axis. So y square varies as x will certainly look like this as our previous learning, because it is symmetrical about x-axis. So that is why a v versus x graph looks like this. And an s versus t graph, as we have just shown you, I'll just repeat it for the sake of clarity again, that the s versus t graph will look like this. So this is your s versus t, which looks like this, and this is your v versus s, which looks like this. Now, the question remains that why at all they are like this? Because of their equations. Because here it is s is equal to half a t square. Again I repeat, which is the equation of y square varies as x. And this is of equation, as you can see, this is y and this is x. So this is again an equation of v square equal to 2as. So when it is v square equal to 2as, we can have it is as a form of a very simple situation of y square varies as x. Well, I'm sorry, this is not y square varies as x. This is actually x square varies as y. So these are the two different forms where you have y square varies as x and you have x square varies as y. So these two makes the difference of a particular parabolic form. So this is all we have right now for coordinate geometry. Thank you.
For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.